It seems like being an astronaut might be one of the coolest jobs there is, doesn't it? Check this out. What I'm going to show you are clips of real astronauts on board the International Space Station. Imagine what it would be like to get to do things like this. Even simple things like using a fidget spinner get a whole lot more interesting in space. Or imagine even getting to play soccer in space. And it's not just all the fun things you can do when you're weightless. Think of the views, too. Seeing the Earth out your window. But you might have heard that being an astronaut is a dangerous job, too. That outer space is a surprisingly dangerous place to be. Why is that? What things do you know about outer space that make it so dangerous? Space is a surprisingly dangerous place to be. For one, you probably thought about the fact that there's no air, no oxygen, so without any kind of oxygen to breathe, you'd suffocate. But you might also have heard about the extreme temperatures of space. And they are extreme. If you're floating out in space in the sunlight, it's so hot it's boiling. Temperatures can reach over 250 degrees Fahrenheit. But as soon as you're in darkness, like over on the nighttime side of the Earth, it's so cold, it's minus 250 degrees Fahrenheit. Way colder than Antarctica. And these are just some of the dangers of space. There are other dangers too, like harmful rays from the sun. We've solved these problems by having astronauts stay inside the safety of their spacecraft, like the International Space Station, which is built of strong metal walls and windows made of 4 layers of super strong glass. When astronauts do need to go outside the spacecraft, of course, they wear spacesuits, made of special materials that protect them from the extreme temperatures. Without their spacesuits and spacecraft, astronauts wouldn't survive more than a few seconds. There's a different kind of danger, though. One that comes not from being outside the spacecraft, but inside of it. What dangers do you think there might be living inside the spacecraft? Today, it may seem obvious that human beings can go up to space and do just fine. Lots of astronauts, more than 500 of them, have gone to space and survived. And as you saw, they even seem to be having a really good time while they're there, floating and flipping around. But scientists have continued to study astronauts who spend longer and longer amounts of time in space, and they've discovered some strange things that start to happen. Just recently, scientists at NASA studied what happened to astronaut Scott Kelly after he spent a year in space. That's one of the longest times anyone has ever stayed in space. To study what happened to Scott, scientists looked at his traits, or physical characteristics, and they compared what he was like before and after he went to space. Traits include all of the things you notice about someone when you look at them, like what kind of hair they have, if they have hair, the color of their eyes and color of their skin, and how tall they are. Traits can also include things you can't see directly, but that you might be able to measure. Like, you could measure how strong someone is by testing how many weights they can lift. Or you could test how fast they run by timing them with a stopwatch. Scientists noticed changes in some of Scott Kelly's traits after he'd been in space. If you had to guess, which traits do you think might change from being in space? In today's activity, you're going to discover how spending time in space could change some of your traits. Now, we can't send you to space for a year. I wish I could help you there. But you can measure some of your own traits, just as scientists measure the traits of astronauts. Then you can think about whether being in space might change those traits. You'll take a look at how astronaut Scott Kelly's traits changed during his year in space. We'll show you how to get started, step by step. Find a partner. You'll work together to make some measurements. Get these supplies. Now we're going to try to do push-ups in outer space. Now, we can't really go to space, but astronauts say that doing push-ups against a wall like this is similar to doing push-ups in low gravity, like on the moon. So let's try it. Both of you, find a spot where you can lean against a wall like this. Do 5 push-ups against the wall. How does it feel to do push-ups on the moon? When you're done, go back to your desk. You found out that push-ups are easier to do on the moon. Here are 2 predictions about what might happen to your muscles in space. Discuss. Here's what happened to Scott Kelly. After his year in space, Scott's arms were weaker than they were when he left Earth, and he couldn't do as many push-ups. He had to do many push-ups on Earth to make them strong again. Knowing this, what do you think would happen to your strength and why? Fill in this question on your worksheet. Before astronauts go to space, scientists measure astronauts' balance. You're going to try that test now. With your partner, find a spot where astronaut A has room to walk in a straight line for 15 small steps. Astronaut A, write how many steps you took without losing your balance. Astronaut B, now you walk while astronaut A counts. Then, you're going to predict whether your balance will get better or worse during a year in space. Discuss. Before Scott Kelly left for space, he could walk 10 steps with no problem. But look at this video of when he got back to Earth. Discuss. On your worksheet, predict what your balance would be like after a year in space. One trait that scientists always measure is how tall an astronaut is. So you'll want to measure your height. Astronaut A, find a place by the wall, with your back against the wall and your feet flat on the floor. Put astronaut A's sticky note on the wall to mark the top of astronaut A's head. Then, switch roles so that astronaut A marks the top of astronaut B's head. Discuss. Scientists measured Scott Kelly's height before he went to space and after. When he came back after a year in space, he was 2 inches taller than when he left. Discuss. Today, it's pretty unusual for astronauts to spend a long time in outer space. But in the future, we're probably going to want to spend longer and longer amounts of time in space. For example, a trip to the planet Mars and back, that takes longer than a year. And what if we just want to live in outer space? Or travel to faraway planets? We could be in space for a long time. On journeys like that, we might even want to take our pets with us too. How will living in space a long time affect our bodies, let alone those of our pets? Well, as you saw in the activity, when astronauts spend a long time in space, some really strange things start to happen. We saw that when astronaut Scott Kelly spent a year in space, his muscles got weaker, his balance got worse, and he got taller, even though he was an adult and was finished growing. These traits changed while Scott was in space. But why? If we look closely, we'll find that all of these traits have something in common. All of them are traits affected by gravity. For example, consider your muscles. Back on Earth, your muscles are always working against gravity, whether jumping rope, picking up your feet to run, or lifting heavy things off the ground. Gravity is always a force that pulls things down. The more your muscles work against that force, the stronger they get. But in space, there's practically no gravity that your muscles have to work against. You just float around. Life in space is easy. In fact, it's too easy. When your muscles aren't doing any work, they start to shrink and get weaker. And this same thing is true for your bones. Just like your muscles, they get weaker too because they don't have to support your body against the pull of gravity. After a year of taking it easy, the muscles that kept Scott Kelly standing up and walking had gotten very weak. Scott's strength and balance had both gotten worse, as you can see in this video, taken shortly after he returned to the Earth. Scott also got taller in space, even though he was an adult and his body didn't grow anymore. That might seem really weird, but it also has to do with gravity. Scientists have studied the human body and found that in between the bones of your spine, there are squishy pads that act like cushions. On Earth, those squishy pads get squeezed down because of gravity. But when you're in space, it's like your spine is always relaxed and stretched out. There's no gravity to smush those squishy pads like there would be on Earth. So in space, you actually get a little taller. It doesn't last forever. Once you return to Earth, gravity will quickly make you go back to your normal height. So we can see from astronauts like Scott Kelly that traits can change based on the environment you live in and the experiences that you have. Some changes won't hurt you, like getting taller, but other changes, like losing your muscle and bone strength, those can be dangerous for your health. In the future, if we start sending people and even animals to space for a long period of time, we're going to have to solve the problem of how to keep ourselves and our pets healthy. What kinds of things could we do to make sure that our bones and muscles stay strong? Well, astronauts like this astronaut running on a treadmill exercise for 2 to 3 hours every day while they're in space to try not to lose their strength. They have to work out on special equipment, like this treadmill that has a harness to keep them from floating away. It might be tricky to get a dog to go for a run on this thing, and a cat, forget about it. And even with all this exercise, without gravity, astronauts still come back to the Earth weaker than when they left. It may take months or years for them to fully recover, for their traits to go back to normal. Some people have said, if only we could come up with some way to create some kind of artificial gravity in space, then we could avoid these problems. But so far, that's not something anyone has figured out how we could easily do. All of this might seem like a problem for the distant future, but maybe it's something you'll grow up and solve one day. Have fun and stay curious.